Hello guys, good afternoon. Welcome to Spark Tech Academy. Today, as we have gone through all type of DC numerical problems in DC circuits and fundamentals of electrical engineering, now we will be going through Thevinins and Nortons. As already in previous lecture I have told you, we will go through Thevinins and Nortons. Even if it is not in your syllabus right now, it will be helpful to you because as we are learning the DC circuits now, it will become very easy to understand the concept of Thevinins and Nortons in this case. Now I will solve one example and parallelly I will definitely tell you what the Thevinins and Norton's theorem actually is. Let's go now. First we will be drawing the given circuit diagram. This is the point A, point B. Given is 30 volt DC supply. This resistance is of 5 ohms. This is of 10 ohm. This is of 15 ohm respectively. Now what they have asked us to calculate VTH, or you can see VOC. It is nothing but Thevenin's equivalent voltage. And next thing they have asked us to calculate the ISC. It is nothing but Norton's equivalent current. Now first of all, what you will see is that for both these cases, the Thevinins and Nortons, what we will do is first we will calculate the RTH. RTH is nothing but a equivalent resistance where we do the series and parallel combinations, and accordingly we calculate the resistance. While calculating resistance, if the voltage source is given, which will be replaced by a short circuit, means closed switch you can say, and here the resistance will be now we will be calculating the RTH actually. In RTH, what we will do is, as we will calculate the RTH across RAB, that's why this will be open circuited, and here what you will do is 10 ohm, 15 ohm and 5 ohm resistor. You will be looking from this way, that's why these two resistors will be in parallel, 10 ohm with 15 ohm parallel combination in series with 5 ohm resistance. Here, as the parallel combination of two resistors, we will calculate it as R equivalent is equal to 10 into 15 divided by 10 plus 15. Here the value we will be getting is this will be 150 divided by 25, it is nothing but 6 ohm. Now this 6 ohm will be in series with 5 ohm. That's why RTH will be R series plus R equivalent. Here R series is 5 ohm plus 6 ohm. It will be 11 ohm. The RTH is nothing but RAB, you can say. This is the common resistance value which we will be finding to calculate both the Thevenin's as well as Norton's equivalent. Now in Thevenin's equivalent, what we will do is we will calculate one voltage VTH and it will be connected with a series resistance and a RL will be the load. This is nothing but RTH, you can say. This is the RL, this is the load, and the current flowing through it will be I. This is the Thevenin's equivalent circuit. Thevenin's equivalent circuit. Thevenin's equivalent circuit is nothing but whenever any circuit is given or any voltage source with resistance or any electrical parameter circuit is given, that resistance or that circuit will be converted to this circuit, converted to a voltage, open circuit voltage. VTH is nothing but VOC, the open circuit voltage, which will be calculated. In this case, this VTH will be the point which is located at here, the point which is located across here. It is VTH, here is VAB. It will be, the equivalent resistance will be, the equivalent Thevenin circuit will be VTH is equal to VAB in series with RTH, where we have just now found out the RTH, and any load if load is connected to it. In this case it is nothing but this load RTH is nothing but RAB, and no external load is given, no external load is connected, hence RL is equal to 0 in this case. This is Thevenin's equivalent, which I have just now explained to you. Just write it down. Now I will be showing you the Norton's equivalent circuit. This is Thevenin's equivalent. Now you will be going with Norton's equivalent circuit. Please have a look through it. You will find out one thing. The resistance in series with the RTH resistance and it will be in series with RL, it is nothing but a load resistance. When load resistance is given, in this case the load resistance is 0, as no resistance is connected across point A and B as a load. That's why here we have calculated in this case no load resistance is given. This is nothing but a circuit where we found out these things. When that is given, the same way we will calculate the power also by maximum power transfer theorem. Now I will be showing you the Norton's equivalent. Norton's equivalent is nothing but current source in parallel with RTH, or you can say it as RN. RN means Norton's resistance, you can say Rn, and this will be nothing but the load RL connected. Here it will be ISC. Here the two currents will be getting divided. Here it will be ISC. Here will be IN, you can say, and here you can look after the IL. This is Norton's equivalent. The Norton's equivalent circuit is nothing but when any circuit is converted to a current source in parallel with R and the equivalent resistance and the load. You can convert any circuit to this circuit in order to get the Norton's equivalent circuit, where they have told us to calculate the short circuit current in this case. That's why the short circuit current will be related to Norton's equivalent current, and VTH is nothing but open circuit voltage for Thevenin's equivalent voltage. This is the real difference in between that. Please note down the Norton's equivalent circuit also. Then we will calculate the VTH and ISC in this case. Okay. Now I have already shown you how we are going to calculate the VTH. In this case, VTH is equal to VOC is equal to nothing but VAB. Now, as if you look carefully, the current through I ampere, I through I 10 ohm is equal to 0 ampere. As it is open, this terminal A is open. That's why when you calculate the VTH will be 30 plus minus. This will be 15 ohm. This will be 5 ohm. And here it is nothing but the VA, it is nothing but VB, you can say. Now what we will do is we will first find out the current I. I will be nothing but 30 volts divided by this series combination 20 ohm. It will be nothing but 1.5 amperes. Now when we get I will find out the VA. VA is nothing but, VA in this case is nothing but 30 volt minus I into 5. This 30 minus, already I we have calculated as 1.5 into 5. You will get as 22.5 volts. This is nothing but VA. Now VB is at 0 volt as it is connected to earth here. Hence VAB is equal to VTH is equal to VA minus VB. It is nothing but 22.5 minus 0. It is nothing but 22.5 volts. This is the VOC, the open circuit voltage. VOC equal to VAB equal to VTH. This is the Thevenin's equivalent voltage. Just now I have calculated. Please note down carefully. just in this case what we have done is we have just applied the terminal voltage formula over there, or you can say simply V is equal to just difference between two voltages. Voltage is nothing but I into R. Here the voltage is already given, we are just applying the KVL simply and calculating VA, the terminal voltage of point A. Okay, now we will calculate ISC. ISC in this case will be, what we will do is just I will draw a diagram for Thevinins for Norton's equivalent actually, so that you will get it. As this is the point A, this is point B, this is nothing but ISC, this is nothing but 5 ohm, 10 ohm, 15 ohm, and this is already given as 30 volts plus minus. This is the Norton's equivalent, where we will find out the RTH. RTH has already been found out, the same RTH we will be taking there. Only we have to find out the current now. The current will be in Norton's equivalent circuit. The current will be, this is nothing but RN, Norton's equivalent resistance. Here IN will be 30 volt divided by RN. You can say 30 divided by 11. Now 30 divided by 11 is nothing but 2.27 amps. When we get this main current, means it will be the current which is flowing through, here the I will be flowing actually, the I will be flowing through that. Now when you calculate the IA, means this current, actually this current will be the same as that ISC here in this case. Now when we calculate the current IA, it is nothing but a short circuit current. Short circuit current ISC will be I total, it will be a total current IT into, as these two resistors are in parallel, just it is a current division rule. In current division rule, what we do is we will take the opposite resistance. Here in this case it will be R15. It is nothing but current which are flowing through a 10 ohm resistor. That's why the opposite resistor is R15 divided by R15 plus R10. Here in this case 2.27 into 15 divided by 15 plus 10. This is nothing but ISC. Now when you calculate this, you will get as 1.636 amps. This is ISC. This we have calculated first the Norton's equivalent resistance. We have calculated the whole current. This is IT. This is nothing but ISC. The same current will be flowing through here. That's why we will get the current. It is nothing but a current division rule. Current division rule, even I will write here what is current division rule. It is applicable to parallel circuit, and it is nothing but RA, RB. This will be I, this will be the IB, this will be I. This is main current I. Here it will be IA, here it will be IB, this will be RA, this will be RB. In current division rule, what we will get is, when we have to calculate IA will be nothing but total current I into the opposite resistance RB divided by RA plus RB. In same way, we will calculate the IB by just taking other resistance. This way you will find out the current through current division rule. Just now what we have seen is, we have calculated first the Thevenin's theorem. By using Thevenin's theorem we have calculated the VTH, that resistance also, and that current also. And here in this case, same way, the Norton's equivalent circuit, Norton's theorem, Norton's equivalent resistance, as well as the current division rule which is applicable in parallel circuit. Thank you very much for watching eSpark Tech Academy. In tomorrow's lecture or in next lecture, we will be going through some sort of examples where the series parallel combination is already given, and in some cases there is maximum power transfer theorem formula applicable. How it is applicable and how it is derived, we will be going through it in detail. Thank you very much for watching the eSpark Tech Academy.